Mass in is equal to mass out. Whatever is reacting, the mass of that reactants is always going to be same as mass of the product. So we are not going to make new mass in the reaction. Just remember this. We will not create or destroy the mass. We cannot do that. If 5 kilogram of the reactants are reacting, then 5 kilogram of product is going to form. Okay. It is just the law. Okay. Just remember it by heart. So if we have a reaction, as we talked about, any reaction or equation has two main components. One is reactants, another is products. So total mass of elements in the reactant side is always going to be equal to total mass of elements in product side. And that is going to happen all the time. There is no exception to it. Okay, just remember this. This is very important. Now, when you write a chemical equation, it always has to satisfy the conservation of mass. Okay. Now, to make it satisfy conservation of mass, it has to be balanced, and we will talk about what that means. So, now think about what's going on here. In our daily life, let's say we are in Diwali hai, और आप rocket चला रहे हैं, and that rocket, let's assume, has a magnesium. Okay. तो जैसे वो मैग्नीशियम अपन लाइट करते हैं रॉकेट को, वो ऑक्सीजन के साथ रिएक्ट करके मैग्नीशियम ऑक्साइड फॉर्म करता है और व्हाइट लाइट भी दिखती है अपन को स्काई में. Okay, so that's going on. So if you think about this, all the magnesium which is present in the rocket, let's say it is 1 gram, and it is reacting with, let's say, 2 grams of oxygen. So 1 gram of magnesium is reacting with 2 grams of oxygen, and then it forms magnesium oxide. So now we know from conservation of mass that a mass of that magnesium oxide is going to be 3 grams, which is 1 plus 2, right? So this is the reality. This is going to happen in actual life. Now we are representing this equation by this word format, which is magnesium and oxygen is going to form magnesium oxide. Okay. This equation also has to follow that law, because reality follows the law. So we have to make sure our reactions and the reality is same thing. So that's what we are going to talk about. How to balance the equation, which is chemical equation, which we just wrote down in the previous slides, so that they always follow conservation of mass. So there are two type of equations. One is balanced equation, another is unbalanced equation. So balanced equations are the equations which follow the conservation of mass. Unbalanced one, they do not. So when number of elements in the reactants is equal to product. So whatever is in the reactants, same amount of mass is actually in the product. For example, if you have 4 oxygen atoms in the reactants, then you also have 4 oxygen atoms in the product, and this will make sure that your conservation of mass is applied. So let's look at this equation, which is zinc is reacting with sulfuric acid, and then you are forming zinc sulfate plus hydrogen. In this equation, you see there is 1 atom of zinc on the reactant and 1 atom of zinc on the product. There are 2 atoms of hydrogen on the reactants and 2 atoms of hydrogen on the product side. Similarly for sulfur, similarly for oxygen. So number of atoms in the reactants is equal to number of atoms in the product. And this will make sure this equation is following the conservation of mass, because if the number of atoms are same and each atom has the same mass, then the mass in the reactants would always be equal to mass of the product. Unbalanced equation doesn't have this. In unbalanced equation, the number of atoms in the reactant is not equal to number of atoms or elements in the product. Okay. So for example, this magnesium and oxygen reaction we talked about, we have 1 atom of magnesium in the reactants and 1 atom of magnesium in the product. So that is fine. But if you look at oxygen, we have 2 atoms of oxygen in the reactants, but we only have 1 atom of oxygen in the product. So this is not balanced, and that will not follow the conservation of mass. So we have to make sure our equation follows the conservation of mass, and we can do that by balancing it. Okay. Now, how do we balance equation? A couple of ways. First one is just hit and trial. For example, in the equation you're looking at, if you just put some of the numbers on the reactants and product side, then you might be able to balance it. So the example we talked about, magnesium and oxygen going to form magnesium oxide, which is not balanced, right? It's unbalanced equation. If I have to write the element and then number of atoms in the reactant and number of atoms in the product, as you can see, magnesium, we have 1 both in reactant and product, but oxygen, there are 2 atoms in reactant and 1 atom in the product. So if we just multiply the equation, like in the reactant we multiply the magnesium by 2, and in the product we multiply the magnesium oxide by 2. When you put that number there, it will become balanced. So this is the hit and trial method, because we are trying to just eyeball it, just trying to guess what the number would be, and then if we get lucky we would be able to balance it. Simple equation like this can be balanced like this, but there are complicated equations in which you have bigger molecule, you have more atoms, you have a lot of products, a lot of atoms, and then it would be a nightmare to actually balance by hit and trial. So there is a more systematic approach. So first step in that systematic approach is basically to draw boxes around each of your formula in the equation. So in this systematic approach, we will see an example of iron is reacting with water. So first we draw a box around each and every formula. Next, we list down the number of atoms of different elements in that boxes. So as you can look, there are 3 different atoms here: iron, hydrogen, and oxygen. So number of atoms in the reactants is iron is 1, hydrogen is 2, oxygen is 1. But number of atoms in the products, iron is 3, hydrogen is 2, and oxygen is 4. The third step is basically, now you select an atom which has maximum number in reactants or product. So in this equation, we can see oxygen in the product has maximum number of atoms of 4, right? So to balance, first of all, we will start with balancing the oxygen atom. To balance the oxygen atom, we just multiply that oxygen atoms in the reactants by 4, because we have 4 oxygen atom in the product. So as you can see in the equation, in the box equation, I multiplied on the left hand side, that is the reactant side, only the water molecule by number 4, because water is the only molecule there which has oxygen. So now if you look at the equation, which is partially balanced because their other atoms are still not balanced, but we have same number of oxygen atoms in the reactant and in the product. Another very important point to note is you cannot modify the formula, okay, or reactant in the equation, and that's why we put the box around all the formulas, and that's so that you cannot change the formula. So water, you cannot make it H2O4 to balance the oxygen, or H2O and then bracket 4 to balance the oxygen. Okay, that is not, you cannot change the compound. Okay, you can only change the number of that molecules. Now that's why putting a box around to make sure we don't make a mistake. Okay, so now we have a balanced equation from oxygen point of view. Our hydrogen and iron is still not balanced. So as you can guess, our next step would be to balance with either hydrogen or iron point of view. So let's say we want to balance from hydrogen point of view. Okay, so we have in reactants we have 8, and in products we have 2. So what we can do, we can multiply the product by 4, so we will have 8 in the reactant side and 8 in the product. So that you can see in the box equation, I have multiplied the output, which is the product, by number 4. Now we have 8 atoms of hydrogen in the reactants and 8 atoms of hydrogen in the product. So this equation is balanced from hydrogen point of view. But our iron is still not balanced. So let's do the same exercise. We see that we have 1 atom of iron in the reactant and 3 atom of iron in the product. So we multiply the reactant by 3. So we will have 3 in the reactant side and 3 in the product. As you can see in the box equation, our iron atoms are also balanced. Now we have a balanced equation, but we have to do a final check. And that is basically to make sure we have done our job right. We just list down all the elements and then number of those elements in the reactant and number of those atoms or elements in the product. So iron we have 3 3, hydrogen we have 8 8, and oxygen we have 4 4. Now we can be sure that our equation is balanced. And we can also say this equation obeys the conservation of mass. Alright. Another important thing to note is like we do add few more characteristic in equation, that is to add some more information. For example, if we have a solid in the equation, we put a little s there just to make sure we know that it is solid. Similarly, for liquid, we put in the bracket small l, small g for gas, and if say our reactant and product is in solution of water, we put aqueous, which is aq dot. Okay. Now let's look at previous equation. Our iron was actually solid, so we put S there. Our hydrogen was actually in the form of steam. We are not using the liquid water, we are actually using the steam, and that's why we put G there. The product we are forming, similarly we put the states, physical states in the product too. As you can see, our hydrogen is actually in the gas form. So this is not all the time we add these information, that is the physical state, but if required. There are other examples of balance equation, and I would recommend all of you to actually look at the equation and try to balance it yourself and check the results.